question 9 of the May 2018 paper 1 AS Edexcel paper. So really two parts to this question. The first two bits A and B are really one part, and then this is the second part. The first part is talking about the factor and remainder theorem and factorising, etc. And then we move on to doing some graph sketching, okay, and transformations, okay. Let's look at part A first, okay. So it says use the factor theorem, okay. It doesn't say that we can do it any other way. We have to be able to use the factor theorem and understand what it is, okay. And the factor and remainder theorem are basically the same thing. It's just that when we plug a number into this function, if it equals to 0, it is a factor. If it equals a different number, then that number is a remainder. Okay, and the trick here is that when you've got the bracket x plus 2, the number that you would want to plug in is not plus 2, it's minus 2. Okay, so we've just got to work out what the function is when we put minus 2 in. If the result is 0, it means it's a 0 remainder, and that means that it's a factor. Okay, so we're going to work that out here. Obviously you can use your calculator quite a bit here. Okay, I'm not going to use a calculator, but you guys can. So by all means pop that into your calculator, and if it equals 0, we've shown that it's a factor. Okay, I'm just going to do this quickly, keep my brain sharp and do stuff without calculator. So minus 2 cubed is going to be minus 8. Okay, minus 2 squared is 4. And then this is going to be plus 30, and this is going to be plus 50. So I'm going to get minus 32, minus 48, 30 and 50 are 80. And you can see that minus 32 minus 48 is minus 80. Okay, and then obviously plus 80. This equals 0, and therefore x plus 2 is a factor. That's really using the factor theorem. Okay, like I say, if you've got a different number, you're just finding the remainder. So try not to think of the factor and remainder theorem as different things. They're one and the same thing. Okay, so that's part A. Okay, so part B then, it wants us to fully factorise this function. Okay, now of course, because we found that x plus 2 is a factor, we know that it's going to be x plus 2, and then we know we're going to have, really, when it's a cubic, you can see that this is a cubic function, you're going to get 2 more brackets. But it's actually telling us here that it is a bracket squared. So it gives us a little bit of a hint. But ultimately, in terms of trying to work it out, we've got to divide the function by x plus 2. It's the only way that we can get, at first, a single bracket in here. And hopefully it should make sense to you that it's going to be some form of quadratic. Okay, because that's the only way that we could get a cubic, isn't it? We have a linear factor here, okay, and a linear factor times this quadratic is going to produce a cubic. Okay, so how do we do that? Well, we take our cubic and we divide it by this linear factor x plus 2. Okay, so very important method this. Okay, the first starting point here is you look at how many x's go into this first term here. Okay, so we're effectively doing 4x cubed divided by x, so that's going to give us 4x squared. Okay, and the method here is you multiply this 4x squared by your linear factor, and you write it, well, where I'm writing it, okay? And the reason that we write it there is because we then want to do a subtraction. Okay, now if you've done this correctly, these two will always cancel out. Okay, in other words, give you 0. So now, if I read this correctly, I'm doing minus 12x squared minus 8x squared. That's the important thing, that I'm subtracting this. Okay, so that's going to give me minus 20x squared. Okay, and then you really just restart again. I do x into this term. Okay, so that's going to be minus 20x. And again, I then multiply that by the linear factor. Okay, so I'm going to also get minus 40x. Now, there's a couple of things you can do. You can either then subtract these two terms here, or what I see a lot of students do is they want to write that minus 15x here and then subtract them here. It doesn't matter, as long as you are doing minus 15x minus 40x on the next line. Okay, so sorry, I must restate that more correctly. Minus 15x minus 40x. we're subtracting the negative 40x. So that's going to be the same as plus. Okay, so I'm going to get a 25x here. And then I start again. I do x's into that. That's going to be plus 25. Okay, and you write the 25x here. Multiply that by 2 is 50. And then again, you subtract these two 50s and you get 0. And when you get 0, that shows you that, kind of gives you confidence that you've done it correctly, because we already knew that x plus 2 was a factor of this cubic. Okay, so if we didn't get 0 at the end, we've done something wrong. So I've just cleared the screen a little bit, and this is really what we need to put in here, is what we got at the top of our division. So it was 4x squared minus 20x plus 25. Okay, and then we need to factorize that quadratic into two brackets. Okay, now normally, you know, you've got different methods for doing this, but we've got a really big clue in this question. Okay, this question has told us that it's a what we call a perfect square. Okay, so the only way, if we're going to do a perfect square and get 4x squared, is if the front is 2x and 2x. Okay, and the only way that you can do a perfect square and get 25 on the end is with a 5 and a 5. Okay, and we've already been told that the two brackets are the same. So you write this out, and then maybe you just double check it. Okay, now if you look at that, if I double check that, I'm not going to get minus 20x in the middle. Okay, so I just go back and I change my two signs to minus, and then I double check again. And I think, oh yes, that's going to work. I'm going to get 4x squared, I'm going to get minus 20x, and I'm going to get plus 25. Okay, so when you look at the form of this answer, okay, A is equal to 2, and B is equal to negative 5. Okay, so that's the final answer to part B. So moving on to part C then. Okay, we're still dealing with the same function. We're still dealing with this g of x, which is up here. But we know that we've written this in a different form, so let's just get that jotted down again. This is our factorized version of g of x, okay? And in factorized form, we can start looking at this graph and working out what some of the values are, okay? So this one here must be negative 2, okay? If you think about what we're trying to do when I'm looking at where it's cutting the x-axis, is that's when y is equal to 0. So imagine solving this equal to 0. Minus 2 is going to be one of your answers, and then from this bracket, well, 2x minus 5 would need to be equal to 0 if you add 5 to both sides and then divide by 2. You then get your other coordinate here, which is 5 over 2, and it's what we call a repeated root, okay, because it's 2x minus 5 squared. Okay, it means that the graph just touches rather than cuts through there. Okay, so that's a really useful thing. Before we even look at the rest of the question, it's really useful to get those 2 points on there. Okay, so what is it asking us to actually do? In part C, it says use your answer to part B and the sketch, deduce the values of x for which. It says when the function is less than or equal to 0. So let's draw that and visualize what it means. Okay, when we're talking about the function, really, we can cross this y out and think of it as the function. Okay, so it's really, when we say when is the function less than or equal to 0, it means when y is less than or equal to 0, and it's going to be this little red bit of the graph that I've drawn. Okay, and then it's really easy to see what the answer is. Okay, it's when the x values are less than or equal to minus 2. Okay, so as long as we're going to the left of minus 2 on the graph, we're going to continually get a negative value for y. Okay, now the second part then, II, let's do a different colour for that one. Okay, this is asking for when this is equal to 0, but it's a slightly different function. This is a graph transformation. Okay, so if I was going to sketch this graph transformation, okay, it would be, I would basically draw exactly the same graph, but I would then just put different values on it. And this graph transformation, the 2 is inside the bracket, so horizontal transformation. And horizontal transformations do the opposite of what you think they would do. Okay, this looks as if we should multiply the x values by 2, but we do the opposite, we divide by 2. So this is going to become minus 1, and this is going to become 5 over 4. Notice how, because it's a horizontal transformation, I can really just draw the same graph but just change the values. Okay, so it's asking us where is this exactly equal to 0. Well, that's these 2 points. That's exactly what I've found. So it's x equals minus 1 and x equals 5/4, or put it as a decimal, 1.25. Okay, that's the final answer for that bit.